So my name is Katarina Brookfield. I'm part of the technical marketing team in the VCF division at Broadcom. And today I'm here to talk about our enterprise workloads and Kubernetes and maybe what we're doing in this sort of like modern app space and everything else within VCF. So I would like to start with maybe providing a little bit more of clarity of what we are doing with VCF and how are we harnessing the power of not just the compute, but also the underlying storage and networking that the VCF offers. So what we do in this space, we have actually embedded a declarative API into VCF. And this is called vSphere Supervisor that allows our customers to deploy workloads. And those can be any workloads, whether they want to be deploying Kubernetes clusters to support their containerized workloads, or if they want to deploy virtual machines using maybe some of these new methodologies, they are able to do that as well. At the same time, we understand that customers maybe need some sort of like resource isolation that we provide within giving our customers the ability to deploy these workloads into vSphere namespaces. Not only provide resource boundaries or allocations, but also give the VI admins the power to set governance and management policies, like, for example, access or determining certain type of access to storage or networking settings and so on. But private cloud is not just about your runtime. And we understand that your workloads need more than just the basic deployment. And so our customers need to be able to expand the capabilities of this platform to match their own requirements. And we do this with the use of supervisor services. And these services allow us to provide any additional IaaS services, PaaS services, or anything else that you would need on the platform. So taking the containerized workloads as an example, our customers would probably want to have a private container image registry running on their platform directly, so they can use supervisor services to deploy something like Arbor. Or if they need to provide ingress to their applications, they can deploy Contour or any other tools. We do have a broad catalog of these items. But what is also very important, if our customers want to maybe deploy, provide data services with self-service, they can also use DSM to self-service databases. But most importantly, they can do all of this on the same platform as they are using for their traditional workloads. So what we mean by one destination for all workloads, it means that VCF is capable of running your traditional workloads and your modern workloads all in one place. So everything that I have shown you on this diagram is provided by VCF. So I just want to make that clear. I'm not here to talk about the Tanzu advanced services, but just to provide a little bit of clarity, everything here is VCF. And when we are talking about the personas, and we were talking about VA admins, maybe building this and setting some policies, and then consumers consuming these services, you would think of those additional services on top being really so provided by Tanzu being more developer focused, or think of it from the app perspective. We're doing infrastructure, that's more the app centric, your app engines, your availability targets for applications and so on. So again, I'm going to be focused on what VCF provides. I just wanted to give you a little bit more clarity in that. But let's see how that works. I will be doing two brief demos. And in the first one, I will show you how you can deploy Kubernetes clusters with our vSphere Kubernetes Service, VKS, which is our Kubernetes Service offering, and how easy that really is. But also, I want to show you how you can use the same unified management tools and the same principles and apply them to virtual machines to deploy those using VM service to cater to all of your application needs. Because as we know, even in the modern app space, applications are not just about containers. Some certain applications still need virtual machines and what they provide. So maybe you will end up with hybrid applications, but with the benefits of managing all of them using the same set of tools. So let me quickly...
Hey, Katrina, could you go back one slide?
Yeah. Ooh. Let me go there.
There. So what's a supervisor? What are vSphere pods? Are they Kubernetes pods? Are they VMware solutions?
So that's a very good question. vSphere pods are our own implementation of a container runtime They're really small. They behave as a Kubernetes pod, but they are running directly on our platform. They're very small and very efficient. What we use them for is to deploy those supervisor services. So when you deploy vSphere pods, you would be able to see them in your inventory. But again, that's not something you would be directly deploying, but something that gets deployed when you implement the supervisor.
So they're not really customer-oriented services, but rather internal services to support customer-oriented services. Is that how I read that?
That is very correct. If you really wanted to, you could use them for your workloads. However, they come with their specific limitations because they've been built for a purpose. So if you would understand those constraints, you could use them for workloads. But generally, we say that those are services that we use to deploy the supervisors.
Okay, thanks.
Okay. Let me just jump into the demo then. So as I mentioned, we will start with the deployment of a Kubernetes cluster. And what I want to show you first is we will be doing all of this from our local consumption interface. And this is a new interface we have implemented that makes it so easy for our customers to deploy, whether it's Kubernetes clusters or virtual machines, as you will see, even without having to have any specific knowledge about Kubernetes. So if we want to deploy a cluster, we will just very quickly go and open the tile and create a new cluster. Now, our customers can choose the cluster class that they want to use. And if they would want to deploy a very quick Kubernetes cluster, they could do it in the default configuration, just hit next and finish. So you would have a ready cluster in really 2 clicks. But for the purposes of this demo and to show you the capabilities, I'll do custom customization. So first of all, I can define a name for my Kubernetes cluster. I can select the cluster class, and then I can select something that's called a Kubernetes release. Now, these are the images that we provide for our Kubernetes clusters. And since we have implemented the independent VKS service, as was mentioned by Rick earlier, we have been really able to fast-track the delivery process of our Kubernetes releases. And the first independent release of VKS already fully aligned with upstream Kubernetes and delivered version 130. And just recently, we have released a new version and now fully aligned with 131 as well. As for networking, our customers can choose from either Andrea or Calico overlays. And then we can go ahead and configure the control plane of our Kubernetes cluster.
Katerina,
again, yeah.
Just a quick question on Antria versus Calico. When would you want to use one over the other?
It really depends on your own maybe preferences, what you are doing with the Kubernetes clusters, what you are implementing this with. I would say probably most common we see is Antria, and also there's a lot of integration with Antria and NSX that is automated in our sense, but you can choose what you prefer.
Okay, thank you.
Okay. So after we've selected a count of replicas, we'll select something that's called a VM class. And VM class is really just a resource definition for the virtual machine that will be underlying this Kubernetes cluster, specifically the control plane node. We offer 16 t-shirt sizes out of the box, but we also give our customers the possibility to create their own custom one to match what they need. So I'll just go ahead and I'll select the number of replicas. I'll select the VM class to configure the control plane node. I can select the storage policy, which basically just points to the data store that I want to use for this workload. And then for OS, we offer Photon or Ubuntu that you can choose. Okay. And then we will go ahead and we will define our node pool. So these are the worker node pools that you create for your Kubernetes cluster. Again, you can give a node pool a name, select the number of replicas, and here you can select your VM classes again, but this time to configure your worker nodes. So if you would be creating custom VM classes, for example, if you have workloads that require GPU, You could create a custom VM class that has PCI device pointing to a GPU that will be added to the node. Again, we're doing storage classes and the OS. And when it comes to the workload nodes, in this menu currently you have Photon and Ubuntu, but in our latest release, we have just introduced support for Windows containers as well, for Windows. And if you need to, you can also, in this flow, configure an additional persistent volume. So for example, as I mentioned, those GPU use cases, if you are running, for example, NVIDIA GPU operator, they're quite heavy on storage that they require. In this flow, I can request extra space for a containerd or kubelet, and this will be provided by the platform, by the volume service for me automatically. So that's the really seamless integration with the underlying hardware we see. And also I can mix and match. I can create another node pool, maybe with different configuration of my sizing, or maybe with a different OS that I need. And the last thing I want to really highlight here is, as you will see on the right side, the full Kubernetes YAML manifest has been automatically created for me and updated with all of my configuration options. Now, this is really important, especially for those customers who are new to the space, are not familiar with the YAML formatting. This is making it really easy for anyone to deploy this. And here I have the possibility to also download this manifest or also copy it to my clipboard if I would want to maybe reuse it in another environment, or if I want to just interact with the API directly using my command line. I could do that here. So all that's left to do here is to just finish. And in a while, we will see that our cluster will be deployed. And then I can simply go and have a look at the running configuration if I want to. So the running YAML, I can download my kubeconfig file here, see the cluster. But also right in this view, I can go ahead and look at all those other resources we have deployed. So every Kubernetes cluster, the control plane will be fronted by a load balancer. So this was automatically created for me. And again, we added an extra persistent volume for one of our worker nodes, so we can see that here. And because, as I mentioned, all of these Kubernetes clusters are deployed as virtual machines in the backend, we will be able to see the virtual machines listed here. And that brings me to the second topic. And that's how do we take all of these principles that we use in the Kubernetes space and how do we apply them to virtual machines? So let's quickly go through that flow as well. So this time I'm going to virtual machine, I'm creating a new one. Again, I can give it a name, and then I select an image. Now, when it comes to images for VMs, this is slightly different. We do allow our customers to bring their own images. We have a very simple process for customers to create either Linux-based or Windows-based images, and then they can consume them in the platform. But if some of our customers are maybe just new to the space, want to test it out, we also provide some of, let's call them POC images. These are really just the cloud-based images that you can just download and use. And we offer them for Photon OS and Ubuntu.
Is there
Again,
a road
I'm going,
for
yeah.
Windows images?
So Windows images are a bit tricky because of Microsoft licensing. So we cannot offer images out of the box. However, as I said, the process we have to build these images is fairly simple. You just deploy that operating system. All it really requires is VM tools running and a certain version of either Cloud Init or sysprep, which is basic for Windows. So we select the VM class. And here we could just go ahead and deploy this virtual machine, or we can do some advanced settings. And again, this will show the power of the platform really well. So in this space, I can decide that maybe I want to provide some data persistency for my virtual machine. So directly in this flow, I can go and request a persistent volume. So I will do that. I could enter some SSH keys into the box, but also I can deploy a load balancer to front this VM. So in this example, what I'm doing, I will be opening this VM on port 22 so I can SSH onto it later. And again, this is the seamless integration with the network service, which will go ahead and create a load balancer for me. And lastly, the most important section, we're not just deploying virtual machines as an empty box. We're doing a full configuration if we want to. So we do support both Cloud Init for Linux-based systems, as well as sysprep for Windows-based operating system. And what we are doing with here is we are passing our cloud config configuration to the VM at first boot to fully configure it, or to do any configuration that we want. In this simple example, all I'm doing is I'm creating a user called DevOps that I use to log into all of my machines, and then I'm running some commands. So for example, I'm updating my packages, I'm installing tools, kubectl and kubectl vSphere plugins, so I can log into the supervisor. I'm also installing my vCenter certificates because I want to log in securely to the supervisor. But this is the really interesting part. The persistent volume that I have just requested, as soon as that's in place, I will also mount it directly in my operating system. And then I will go ahead and install some tools. This is just an example of a machine that I use in all of my environments. So it has some of the tools that I use regularly. And again, on the right side, you will see that, again, everything has been created for me for all of those objects that I am deploying. So whether it was the virtual machine itself, the secret that is passing through the cloud config information, the load balancer, and if I would scroll down a little bit more, we would also see the persistent volume. And now we can just go ahead. And again, if I want to, I can download all of these YAML files. And the reason why I'm showing this is to show you the possibilities that come with this. Because all of my infrastructure is now defined in my YAML manifest, I could grab these and use them in any of the other tools. If I want to pass them to a continuous delivery tool, I could do that to deploy anything onto my platform, store them in GitHub to have my code in one place. And everything else that you would see within the CNCF space now with these new methods of deploying also virtual machines, we can apply those to our workload. In a minute, we will see that the VM will be deployed, powered on, and configured with an IP address. And again, within the same interface, I can go ahead and look at first the volume that I requested. I can see that it's there, right? And I can also go to network service and grab the external IP address that I can use to connect to this box. And just very briefly, I will connect to this just to prove everything. All of that configuration that I passed through using Cloud Init is in place. I'm logging in as DevOps, that worked. I'm logging into my supervisor. If I don't get any certificate errors, it means that my certificates are installed correctly as well. And just as a last thing, I will just make sure that my persistent volume is mounted as I wanted it. So that was the end of these demos. I'm not sure how I'm doing on time. If I would have 2 more minutes, I could show you that demo that Rick has mentioned with the independent update of VKS, but I'll just wait for confirmation if we are okay.
Yeah, I guess it depends on how long Vincent's section is, but yeah, maybe go ahead and go through it. I think we've got a little bit of time.
Okay, cool. I just want to show it because it's really simple, but at the same time, it's really interesting. Just very briefly, as we have mentioned, we have decoupled the VKS service from the vCenter delivery. And what this allows us to do is to allow the admins to update the service as soon as a new version is available. And because VKS is deployed as one of those supervisor services I mentioned, it's really important just to notice that with supervisor services, there are 2 types. There are core supervisor services, which get deployed as soon as you deploy and enable a supervisor. So every core supervisor service will come with an embedded version. Service is now delivered. But now, because we can also go and grab a new version of the service, we can just very quickly go and here I'm just checking that the version, for example, in this was 130, wasn't compatible with my platform. I can go ahead and get the new version of the service. So all I'm doing, downloading one very simple YAML file, I'm adding a new version, uploading the new version. I do not have to change anything in the configuration. And as soon as that version is active, I can go ahead and see it's available. I will install it. Again, don't have to change anything with the configuration. And as soon as it is configured, it will be very fast. I can then go ahead and I will just prove that now my new version is available. So I really just wanted to spend this time just to show you how easy it is now to get the latest and greatest Kubernetes releases onto our platform.
Hey everyone, so thanks for joining. My name is Vincent Riccio. I'm a technical marketing manager at VMware Broadcom, and essentially I focus on our automation solutions. So what I'm going to talk about today essentially is sort of dovetail a bit on what Katarina just talked about, right? So Katarina talked about these underlying Kubernetes services, supervisor services, as well as like a VM service and so forth, and storage and networking services that are driven by a CLI or UI approach. But what we've also done is in the tool that I support, VCF Automation, we've also created a sort of this modern IaaS consumption surface that allows us to consume and deploy these supervisor services across your private cloud SDC environment regionally, right, or globally. So one of the things that we're working on or we're doing is essentially providing our customers the choice of consumption, whether it's through the CLI, through a UI, or through what I'm going to show you here, which is more of our expanded automation tool that can do templates, and we can plug a bunch of stuff in, plumb in other components to our Kubernetes deployment, and so forth. So I'm going to go ahead and go through that a bit in the demo. But just down at the bottom, we look at some of these available out-of-the-box IaaS services. Those are some of the things that Katarina was just talking about, right? So deploying a VM, deploying those Kubernetes clusters, and then ultimately going and doing stuff with some of these different services that we have available. And so what we want to do is we bubble this stuff up into our automation tool to allow us to consume it in a project region type of way. So if you look at sort of the purple boxes there where it says regions and IAM and projects and namespace classes, these are things that we can define across vCenters, across your environment, your fleet of systems, and then give role-based access and project-level access to these regions, which are lists of supervisors that are available, and then attach these namespace classes to define policies like pod limits and things like that. Okay, let me just kind of jump into the demo because I think it's going to take me about the remainder of my time to get through it. So let me do that real quick. And so my whole point here really is to kind of show you sort of the consumption model, especially around the self-service catalog piece. Okay, so let me go ahead and get this up here. All right, so essentially this is the VCF Automation catalog. This catalog can be bubbled up through a ServiceNow portal as well, or users can come in here through role-based access and pick and choose things that they need. The things inside of this catalog can be like ad hoc scripts, polyglot scripts from VRO or ABAC, or they can be templates, which we'll look at here today, which are YAML-based source control templates. So what a user will do is they'll come in here and they'll request the machine. What we're doing here is we're actually going to request a deployment. It's going to be built on the TKG services, but we're also going to deploy containers and also deploy a virtual machine through the VM service to create more of that hybrid nature that Katarina was talking about before. We can plug in different things. So we'll give our MySQL VM a name. This MySQL VM will be deployed through the service, the VM service within the supervisor services, and then we'll see that here in the template as well. I'll pick my class size. We'll pick our region. Also put a namespace, a name in here, so that way we can identify this later when we look at our deployment. And then also our control plane nodes as well. So we have the deployment going on here. I'm going to filter out here just so I can see the stuff that I'm deploying, or that the VCF Cloud deployment user is deploying here. So we have our Cloud Field deployment happening. We can see the task. And what we're doing now is we're essentially going to deploy an application. It's going to be that shopping cart application that we saw earlier a couple of times that had the product on the main page. Before we do that, let's talk about one of the things that's kind of important here as you deliver self-service. So as you deliver self-service, one of the things that you need to be able to do is have policies around it. So when users are going in and starting to deploy things and request items and services, you want to be able to have approval policies, lease policies, maybe day 2 action policies, or resource quota policies as well. So one of the things that we'll focus on here, just kind of showing you a little bit, is a lease policy, right? So one question we get asked a lot is, hey, can I, get rid of machines after a certain period of time because I don't want just stuff sitting around, right? So lease policies are real helpful. We can set criteria like what templates or catalog items or who deployed it. If it has a certain, value here, like the template that we just deployed. And then I can put like a maximum lease, which is like how many days can I actually keep this around, and then how long can I extend it? And then what's the grace period? So once it expires, how long do I have before we're actually going to delete it? So I want to actually create this here. We'll just go ahead and cancel out of that. And then what I'm going to do now is I'm going to go into the section where we actually build the template that allows you to see what we did with the form where we requested the application. So in here, we can see our cloud templates. These are essentially YAML-based templates that are agnostic, so we can essentially provision across environments. These are version controlled, and they can be source controlled in Git, Bitbucket, and so forth for that, source of truth and collaboration. When we go into the template, we have sort of a low-code approach where we have sort of the visualization on the left, the YAML on the right, as well as some properties and input sections. So what you're seeing here is basically a namespace that's going to get created. Then we're going to create a TKG cluster and then some containers, as well as a VM down here, that MySQL VM that's going to live within the namespace. Well, that will actually be a VM you can see running in your environment, but we're going to deploy it through the VM service that Catarina just showed. So we're going to automate this through the YAML template. We can see our namespace here, and then also with the namespace, we can tie in things like our namespace classes and things like that. Now, on this MySQL VM, you can see that this is a supervisor resource. So we can see the type here is supervisor resource. We also can pass the cloud init script here for our in-guest customization, as well as the storage class and so forth. So these type of things are stuff that we saw, earlier, but we're kind of bubbling them up into our automation tool here to provide that DevOps, provide that ongoing capability with this. The other thing that we can do is pass things like cloud init scripts. So, for instance, doing things internally, like we just kind of saw as well. So this will add users in here and customize the operating system. Now, if I want to look at the containers that are getting deployed, I can open up this namespace and see a couple things. We've got a web service as well as our DB service on the outside as well. Those are our ingress load balancers. But we can look at our front-end system, right? And our front-end system essentially is going to depend on a number of machines already being built or services already going, but also we can have sort of these inline dependencies, meaning that, over here in this value, I want to pull data like from maybe my ingress load balancer. So in order for the container to kind of see, hey, where's my database host? We're going to port that information in over from another machine on the template. So as I'm building this out and expanding out my application deployment and introducing services like load balancers and stuff like that, I may want to go ahead and pull data that's already being deployed from within this deployment as we move along. So it really helps me to get very dynamic in how I can go ahead and deploy this application.
Vincent,
right, and then we can see,
I know we're looking at basically kind of fixing the problem of self-service and automation, and I love it, but I just kind of seeing your template here kind of made me think about the idea of canary deployments and testing new development and things of that nature. Is there an integration into this in order to accomplish that?
Yeah, it's a good question. So, normally when you look at canary deployments or blue-green type of things, you're usually looking at a pipeline type of situation where you may be chunking things up into tasks. And so we do have some integrations there, and there's some ways that we have customers being able to do that. And in fact, one of the VM services that we have is actually something called Argo CD, and there's an operator there that does allow you some continuous delivery capabilities. But this is really more of like your template. You can't iterate over it. You can declaratively, through code, determine what you want to deploy and then iterate on it over later. But in terms of a canary deployment, you would be looking more at like a pipelining type of system for something like that generally.
Got it. Another question that I have for you real quickly is normally when you're building these templates, you have to pull in the infrastructure that are required. When you're pulling in the infrastructure specifically for these namespace TKG resources that I see on your canvas, are you actually connecting to the supervisor cluster within a vCenter, or is it something else?
Yeah, good question. And if we had more time, I probably would have gone into some of the prereqs. So the idea is inside of vCenter, you'll have your supervisor namespace. You're basically going to create your default namespace. And then what we can do is then create namespaces within that, as well as TKG clusters in that. So there will be some work up front that you'll do in the vCenter, but what you do inside of automation tool is you'll essentially bring in that vCenter environment. And we do that through a cloud account integration, and then we'll see the supervisor services that are already there. We'll see the supervisor namespace there, and then create new ones if we want to, and stuff like that. But so there will be some. We basically just import all that stuff in, just like we import in the VCM policies and that stuff. So there's actually quite a bit of sort of insight into what's already there through this tool, and then we can just create more. But you're right, there is some setup in the beginning, but we do essentially bring a lot of that stuff in by default.
Thank you.
That helps a little bit.
Yeah, Vincent,
great question.
I see that you've got some references to a secrets management of some kind. Where is that secrets management store?
So this secret is basically a Kubernetes secret service. So essentially, this is just going to live, somewhere in the worker nodes, is my guess. But it's not like a vault or something like that.
Right. Okay.
Okay. Good questions. Let me just see if I know I'm kind of running a little behind with time. Okay, so the other thing is, let me just go to resources here, because then we'll be able to look at our deployment. So we can see all the resources that got deployed, the namespace, the DBs and front end services, our load balancer services as well, or our load balancers and times the VM stuff. And then one thing that we can also do is when we click on the deployment, due to some capabilities within our template, we can have sort of this overview tab, and so we can actually click on the URL of the application and get to it, and we're going to pull that from the ingress web service load balancer as well. So that just gets pulled for that inline dependency that we talked about earlier, as well as, so here's the application and got deployed. And so forth. So this is just kind of an example of what you can do from the just the initial deployment. Now, the other thing that we may want to do is also look at the topology. We can see essentially a very similar sort of visual in terms of what we actually deployed. We can take a look at things like the information about the MySQL system and so forth, and get a little bit of information, like if we wanted to go in and find out what was in the manifest and so forth on certain objects, we can do that and so forth. And then I can also delete this entire deployment if I need to. Now, the other thing that I could also do real quick, and I'll just show this and probably wrap it up because I know we're running out of time, is that we also emulate a little bit of sort of that consumption interface that you saw earlier. So we do this at a global level here on the automation side, where we can also, if the user has permissions, they can go in and deploy additional VMs in here, or if the admin needs to go in and deploy additional VMs. That's also available here inside of this interface. So I can do something very similar. Click on the VM image, click on the VM class for the side, whether it's best effort or guaranteed, and still see the YAML for the Kubernetes manifest on the right-hand side, continuing to be built out for me there, and then I can reuse that if I need to, or so forth. Now, the other thing I will also want to kind of keep, just preface here a little bit, is that even though we've been showing a lot of stuff in the, well, at least I have been showing a lot of stuff in the UI, all this can still be done in the CLI. So you can use traditional kubectl commands and scripts and stuff like that to do a lot of what I've showed you, as well in terms of interacting with the component, like deploying the VMs and deploying some of the CCI stuff. But the templates and stuff like that, even though we do have an API for that, and again, you can source control those, that would be created here in this UI. Okay. All right. So in summary, basically what I did was I used our automation tool to string together some components that we have in the vSphere services to essentially provide load balancer services and application, as well as containers and namespace information, as well as along with that came policies and configurations as well for those namespaces. And then ongoing as well, we can monitor and manage it and things like that.